Okay, so we are going to be working on some key features of our graphs. So our main key feature we've already been talking about is our domain and range. So quick little recap. Our domain are the x's and your range are your y's. So we're working a lot with that. We're going to keep working on this. So when we're talking about our other key features here, so we're talking about increasing, decreasing, positive, negative, and behaviors, we're going to be referring a lot to the domain. We're going to be referring a lot with the x values because what we're asking ourselves is, when is this graph an increasing graph? When is this graph a decreasing graph? When is it positive? When is it negative? And it's all about looking at the x's. So you're looking at what are the x values? What are those domain values when the graph is increasing? What are those domain values when the graph is decreasing? Same thing with the positive and negative. You're trying to figure out when is that happening. And the when question is always your domain. So your domain always answers when. When is something happening? I'm sorry, that's very messy. So when we are analyzing our graphs, we're always going to look at the graph from the left to the right. Just like when we're reading a book, we read our books from left to right. When we're analyzing a graph, we're going to be analyzing it from left to right. So increasing and decreasing is telling us what direction the graph is. Is the graph going up, in which case it's increasing, or is the graph going down, in which case it is decreasing? Your graph can have increasing and decreasing parts. It just can't be happening at the same point in time. So as we look left to right, which way is it going? Is it going up or is it going down? And then next, we look at our positive and our negative. Positive and negative all has to do with looking at your y-axis there. Is the graph above the x-axis, meaning your y values are positive, or is your graph below the x-axis, meaning your y values are negative? And so you would state what x values make that a negative, what x values make it a positive is what we're trying to look at. And again, you can have graphs that have some positive aspects to it. You can have some graphs that have some negative aspects to it. It can contain both parts. Okay. And then the last part is our end behaviors. And our end behaviors are simply trying to figure out what direction is that graph going to continue going? Is it going to continue to go up, or is that graph going to continue to go down beyond the part that we can see? So it's trying to analyze which way is it going beyond the way that we can see. All right, so taking a look at my three examples here. I have a linear graph here, I have a quadratic graph here, and I have an absolute value graph here. So we're going to go through all the different parts, not the domain and range, because we've already talked about that. Although we may add it in just for some extra practice. So we're going to analyze these graphs for these different key features to see when it is that happening. So this first graph, graph A, my linear graph here. If I start on the left side of the graph and my pencil follows the graph as I move to the right side, my pencil is going up. So again, as I follow it from the left, I'm going to the right, my pencil is going up. So this is an increasing graph. And as I'm looking at the line and I try to visualize it continuing on to the right, it's always going to be an increasing graph. So this graph is always going to be increasing. So my options that I have down here, I'm just going to go ahead and cross these off. This is always increasing. So we can either say negative infinity to positive infinity, which is our interval notation, or x is an element of the reals. All right. It's never going to be increasing, or it's always going to be increasing. So our interval, set builder, those are the two ways that we say it. You only have to have one there. So because this is always increasing, it is never decreasing. So we're just going to write never. This graph is never going to be a decreasing graph. So let me take a look at the next one. Let's continue working with the increasing, decreasing part. So the first part of my graph for letter B, if I follow it with my highlighter here from the left, my first part is decreasing. So I'm going to write a letter D. The first part of that is a decreasing graph. So as I go from the left, I first start decreasing, and then my graph switches from this point on, and now it's increasing. So I'm going to put a little I there. Oh, you can't see it too well. Okay. So this one has both pieces. This has an increasing and it has a decreasing portion to it. It has both. It happens sometimes, as I said before. So here is where it switches, which is at 3. Oh, so I apologize for my typo. These should be 3s down here. A lot of times they give us our options. So that's why we have our options already. So the values to the left of 3, which are 2, 1, 0, -1, those are our values that are less than. That is where it's decreasing. So when x is less than 3, our graph is decreasing. The values to the right of 3, so 4, 5, 6, the ones that are greater than, that's when it's increasing. So it's decreasing when it's less than 3. It's increasing when it's greater than 3. And then those inequalities I had in that first one, we're going to write those back in here because this is where it was meant to be. So we'll just bring those back. All right. Give you a second to copy those back down. So x is less than -2 or x is greater than -2, x is less than -2 or x is greater than -2. So as I follow this from the left, follow my graph. This first part of this one is increasing. And then right here, when x is a -2, it switches and it becomes a decreasing. Now my values are going down. So again, this change happened when x is -2. So the values that are less than the ones to the left of -2 are increasing. So when x is less than -2, it's increasing. To the right of -2, those values that are greater, that's going to be decreasing. Okay, so whatever that middle spot is, which actually we refer to this as our turning point, because that's when it switches from increasing to decreasing. So like this one right here has a turning point. There we go. So the x value of there, that's when it changes. Okay, so that's increasing, decreasing. Positive and negative. So the positive values are above the x-axis. Actually, our table says end behaviors. Let's do our end behaviors quick. So end behaviors are, again, just the direction that the graph is going in. So you have a left side and a right side. So we're going to have a left end behavior and a right end behavior for all of our graphs here. So I got just left, right, left, right, left, right that I wrote down here. So this first graph, my left side here is going down. It's going to -infinity. So I'm going to say my left side is going down. The right side of my graph here is going up. So left side's down, right side up is for that graph. Graph B, my left side is going up, my right side is going up. So these are both going to be pointing up because they are going to continue in that direction. And then for C, left side is down, right side is down. There we go. Those are both pointing downwards. All right. So then our positive, negative. I'm just looking, I'm noticing my inequalities got switched for that one as well. Okay. So for here, cross out this part. so cross out just that first part for that one. We'll fix the other one in a second. So positive and negative, as I was saying, positive and negative, it's all about that x-axis. Positive is above the x-axis, negative is below. So as I see with this line, I have some of it that's positive here. I have some of it that is negative here. For my second graph there, all of it's up in the positive. There's nothing in the negative for that one. Whereas this one, again, this one has some positive, some negative. So let's take a look at our questions here. So for the first one, this section here is positive, and the x values that are positive are when x is a 1, it's positive, 2, it's positive, 3, it's positive. So when it's a greater than 0, my graph is positive. When my x value is greater than 0, when my x is a 1, a 2, a 3, or 4, it's positive. Negative 1, negative 2, negative 3, negative 4. So when it's less than 0, my graph is negative. All right. So that one, it switches at 0. For graph B, as we were saying, that's always positive. It's always up there. So we can use our inequality notation. Negative infinity to positive infinity. If you do set builder, it would be the XER. But it is never negative. This one's always positive. Never going to be negative there. All right. So we got to fix this inequality here. So x is less than negative 4, or negative 4 is less than x is less than 0. All right. So you got to fix it. So add x is less than negative 4, or, and then add a negative 4 is less than x to that first part. And the rest of it stays the same. So our negative here has two pieces, negative and negative. So I'm going to have two things selected down below when I do the negative, but I'm going to do the positive part first because there's only one of them there. And it's positive. It starts at negative 4 when it's positive. My x is positive, or my y's are positive. My x is a negative 3, negative 2. So from negative 4 until I get to x of 0, my graph is positive. So negative 4 to 0 is when it's positive. For the negative, again, here's my negative 4. So the value is less than negative 4. So like negative 5, negative 6 would count. So when x is less than negative 4, or positive 1, positive 2. So all those values greater than 0 is the other time when it's going to be negative. So there's two negative pieces, so two inequalities that I picked for the negatives. And then there is only one positive section from negative 4 to 0. All right, let's take a look at some kinds of questions that we would have regarding our increasing, decreasing, positive, and negative. So we have this graph here, and they don't show it very well, but those are endpoints on that graph. So there's a start and a stop. This does not continue on forever. So we have the function y equals f of x is shown in the graph below over the interval of negative 7 to positive 7. They're just simply stating what your domain is for you. They're telling us what the domain is. So that really doesn't affect us too much. So they want to know, find the maximum minimum values of the function, state the x value, the values of x when they occur as well. All right, so right here is my maximum value. And then over here, this is my minimum value. So this is the lowest it gets. That's the highest that it gets. So max. Min. So my max happens when x is a negative 1. And then my min happens when it's negative 1, negative 2, negative 3, negative 4, negative 5. When x equals negative 5. I have my minimum value. So find the value, find the maximum minimum values. I did, I found them. State the values of x where they occur. So we didn't state what the actual maximum value is. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7. So maximum value here is 7. The minimum value is -1. We forgot to state that part. Told us to find them. We did. We forgot to state what the numbers were. So there they are. B, what is the y-intercept of the function? Explain why the function cannot have more than one y-intercept. So our y-intercept is right here at 1, 2, 3, 4, 5, 6. So our y-intercept equals 6. We can't have more than one because if we did, then it's not a function. There's more than one, then it's not a function. It would fail the vertical line test if I had more than one there. Okay. Next part. Give the x-intercepts of the function. These are also known as the function's zeros because they are when the function equals a 0. So our x-intercepts are on the x-axis. Just like your y-intercepts on the y-axis, your x-intercepts are on the x-axis. So we have 2 of them. There's 2 times when this graph is on the x-axis. And that's at 1, 2, 3, 4, 5, 6. So when x is a -6 and when x is a -1, 2, 3, 4. So we have 2 x-intercepts, 2 spots where it hits the x-axis, -6 and 4. Would you characterize the interval of -5 is less than or equal to x is less than or equal to 1 as increasing or decreasing? Explain your choice. I'm going to use a green highlighter here. So we go to where x is a -5, which is here. So I'm going to follow my graph until I get to -1. And as I do that, my highlighter here, as I go from -5 to -1, my highlighter is going up. So I would categorize this as being increasing. Explain my choice. The graph moves up as you go from x equals -5 to x equals -1. Graph moves up as you go from the -5 to the -1. That's how I know it's increasing. Okay. Give you a second to copy that down. All right, so give one additional interval over which the function is increasing and one over which it is decreasing. Okay. So there's only one other time when this function is increasing, and it's from here to here. So from here to here. So I got to find my x coordinates for that. So that's 1, 2. So when x is a 2 to when 3, 4, 5 to 5. So I can either write it in interval notation, 2 to 5, or I can write it with some inequalities of 2 to 5. Doesn't matter. Just has to be one of them. So then this graph has 3 decreasing parts. So you could either do here to here, here to here, or here to here. So again, 1, 2, 3. We got 3 decreasing sections to this graph here. So I'm going to put all of the intervals there. Doesn't matter which one you choose, you just have to have one of them. So we can either pick the first decreasing section, which is -7 to -5. There's both our notations for it. You could pick the -1 to 2. There's both intervals for it. Or we could pick the last one, which is 5 to 7. I'll write it up here. So one of those 3 has to be there, but those are the 3, and those are both in the 2 notation styles for both of those there. So then our last question, using the graph below, find the values of the domain for which the function is less than 0. So if it's less than 0, that means it's a negative value. So this question is asking us to find when is the function negative. So again, it's negative when it's below the x-axis. So from here, negative, 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 to there. So that's 1, 2, 3, 4, negative 5, 1, 2, 3, 4, to positive 5. So our two ways of writing it, either interval notation or inequality notation. Either one, doesn't matter which one, as long as one of those is there. So those are our key features.